Picture this. It's January 27th, 1967, and deep beneath the frozen forests of the Kola Peninsula at the very edge of the Soviet Union, there's a concrete bunker buried in ice and snow. Outside, the wind screams across the tundra at 30 degrees below zero, but inside the command center of the Soviet Air Defense Forces, the air is thick and stale, reeking of tobacco smoke and nervous sweat. Senior Lieutenant Viktor Kurolyev sits hunched over his radar screen, watching that same green line sweep across the scope like it has every single day for months. His job is mind-numbing. Occasionally a passenger plane drifts by, sometimes a flock of birds creates a brief flicker of static, but mostly it's just emptiness. Then, at 9 in the morning, something changes. A contact appears at the far edge of his scope, faint at first, flickering in and out near the Norwegian border. Victor adjusts the settings, squinting at the screen, and the blip solidifies. This thing isn't drifting like a balloon, and it's not cruising like a bomber. It's slicing through the grid with a velocity that makes him tap the glass, convinced his equipment must be broken. He grabs his headset and reports the contact, pauses to double-check his calculations, and then says the words that make the entire room go silent. The target is moving at Mach 3. In 1967, Mach 3 isn't a speed for aircraft, it's a speed for missiles, for weapons that explode on impact, not machines that fly with people inside them. The commander rushes over, leaning over Victor's shoulder, asking if the Americans are launching missiles, if this is the start of war. Victor's voice trembles slightly as he explains that no, this isn't a ballistic trajectory. This thing is maneuvering, maintaining altitude, actually turning like a plane would turn. This is the moment everything they thought they knew about physics gets thrown out the window. Soviet engineers have calculated that anything moving through the atmosphere at 3 times the speed of sound generates friction heat so intense it should melt aluminum on contact. To sustain that speed, an engine would consume fuel so fast that a standard fighter jet would be drained dry in minutes. It's supposed to be a sprint, a desperate dash, not a leisurely cruise. But this ghost on their radar isn't sprinting at all. It's cruising. For the next 40 minutes, the men in that frozen bunker watch in stunned confusion as the target traces a lazy, almost arrogant loop along the edge of Soviet airspace. It doesn't slow down to cool off. It doesn't descend for a break. It just stays up there pinned at 80,000 feet where the air is so thin it's practically a vacuum, moving faster than a rifle bullet. The colonel orders an intercept and 2 MiG-21 fighters scramble from a nearby airfield, flown by the best pilots in the regiment. But the intercept turns into a humiliating farce. As the MiGs climb, straining their engines to reach their service ceiling of 60,000 feet, the target simply exists above them, completely untouchable. The Soviet pilots look up through their canopies into the dark purple sky and report seeing a silver streak, a glint of sunlight far above, moving with a serenity that feels almost insulting. They push their throttles to maximum, dumping fuel into their afterburners trying to close the gap. But as they push their machines to the absolute limit, their engines start to overheat and warning lights flash across their cockpits. They're forced to break off and dive back into thicker air to save their jets from disintegrating. The target doesn't react, doesn't evade, just continues its patrol like nothing happened. This wasn't just an intrusion into Soviet airspace. It was a technological paradox that made no sense to anyone watching. Jet engines work by sucking in air, compressing it, mixing it with fuel, and igniting it. But at Mach 3, The air entering an engine is moving so fast and with such pressure that it creates a shock wave capable of choking the engine and causing it to flame out. It's like trying to drink from a fire hose while sprinting at full speed. The heat generated at the inlet should be melting the turbine blades into liquid metal. Yet this machine wasn't just surviving. It seemed to be thriving, almost enjoying itself up there. The radar operators noticed something even stranger. As the object accelerated, its heat signature didn't create the chaotic bloom of an engine struggling against drag like Soviet jets did. Instead, the signature stabilized, and the faster it went, the more efficient it seemed to become. This flew in the face of everything Soviet aerospace engineers understood about high-speed flight. Their own interceptors, like the prototypes they'd been testing, were brutes that achieved speed through raw thrust, fighting the air every inch of the way, vibrating violently, guzzling fuel, and destroying their own engines after just a few minutes of supersonic flight. This American ghost was dancing with the shock waves like they were partners in a waltz. By the time the blip finally turned north and vanished off the scope toward the Arctic Ocean, the mood in the Kola bunker wasn't anger. It was profound insecurity. The Soviet Union had spent billions of rubles building a wall of surface-to-air missiles and interceptors designed to stop American bombers. They built what they thought was an impenetrable fortress around the motherland. But that morning they realized their fortress had no roof. The report Victor typed up that evening was sent by secure courier directly to the Kremlin, and it didn't contain bluster or propaganda. It contained a single terrified question that would haunt the Soviet military-industrial complex for the next 2 decades. How are they doing this? The search for that answer would send the KGB and Soviet engineers down a rabbit hole of paranoia, forcing them to question fundamental limits of metallurgy and thermodynamics. They assumed the Americans had discovered a new element, developed a new fuel, or perhaps invented an entirely new form of propulsion. They couldn't imagine that the answer lay in a mechanical trick so ingenious, yet so counterintuitive that it turned the enemy, the air itself, into an ally. But on that frozen morning in 1967, all they knew was that something was up there looking down on them, and they were completely powerless to stop it. The impossible machine had arrived, and the Great Soviet Panic had begun. The radar tapes from the Kola Peninsula didn't stay in the frozen north for long. Within 48 hours, they were in a leather briefcase handcuffed to a courier's wrist, traveling by train to Moscow, eventually ending up on a heavy oak table at the Central Aerohydrodynamic Institute, the brain trust of Soviet aviation where the finest minds in the communist world wrote and rewrote the laws of aerodynamics. But looking at the flight data of this American intruder, those brilliant minds went blank. A committee formed immediately, including lead propulsion engineers, aerodynamicists, and intelligence officers, and the atmosphere in the room wasn't one of scientific curiosity, it was defensive panic. The data presented a terrifying picture showing the target maintaining Mach 3.2, over 3,500 kilometers per hour, for sustained periods, and this duration was the anomaly that kept the engineers awake at night. To understand their confusion, you have to understand the state of jet propulsion in the late 1960s. The Soviets were masters of brute force. They knew how to make things go fast. They'd built the MiG-21 and were testing the terrifying MiG-25 prototypes, but they also knew the brutal cost of that speed. In a standard turbojet engine, air gets sucked in the front, compressed by spinning blades, mixed with kerosene, and ignited, with the explosion shooting out the back to push the plane forward. But at Mach 3, the air ramming into the front of the engine isn't a gentle breeze. It's a solid wall of pressure, and this compression heats the air instantly so that before it even touches the engine's internal compressor, it's already over 400 degrees Celsius. When you try to compress air that's already that hot, the metal blades of the turbine soften and stretch, and eventually they melt or shatter, turning the engine into a grenade of shrapnel. The Soviet engineers stared at the American flight path, showing the intruder had flown at Mach 3 for over an hour, and one senior engineer argued during a heated session that it was impossible because if they were using standard turbojets, the turbine inlet temperature would exceed the melting point of any known alloys and the engine should have liquefied 10 minutes into the flight. The investigation splintered into different theories, each more desperate than the last. The first theory suggested the Americans had developed a nuclear-powered aircraft, which had been a persistent fear since the 1950s because a nuclear reactor wouldn't need to burn fuel in the traditional sense and could heat air indefinitely, explaining the unlimited range and high speed. But radiation detectors on Soviet border patrols had picked up nothing, no trail of isotopes, no glowing exhaust. So the theory was discarded, though the fear remained. The second theory proposed the aircraft was actually a rocket glider similar to the experimental X-15, perhaps dropped from a massive bomber, lighting a rocket motor to dash across the border before gliding back. But the radar tracking contradicted this because the object didn't glide. It accelerated out of turns and climbed while at speed, and a glider loses energy whereas this machine was generating it at will. The investigation moved from the chalkboard to the cockpit as the Soviet Air Force received orders to visually identify the target at any cost because they needed to see the engines, needed to know if there were scorch marks or strange intakes or rocket nozzles. This order led to some of the most frustrating intercepts in aviation history. Soviet pilots flying the new MiG-25 Foxbat were the only ones with even a prayer of catching it, because the Foxbat was a masterpiece of brute force engineering, essentially two massive engines with a cockpit strapped to them, capable of hitting Mach 2.8, maybe Mach 3 if the pilot was willing to wreck the plane. But the pilots reported a demoralizing reality. To reach the intruder's altitude, the MiG-25 had to accelerate to absolute limit, and pilots described the thermal wall, that moment when friction heat became so intense the canopy glass felt hot to the touch even through their gloves, and they'd watch their fuel gauges with the needle dropping visibly like a clock's second hand. One report from a pilot stationed in East Germany described an encounter over the Baltic Sea where he pushed his MiG-25 to Mach 2.8 with engines screaming and afterburners dumping raw fuel into the exhaust to sustain speed while warning lights flickered showing engine overheat and critical hydraulic pressure. He looked up and saw the Blackbird 10,000 feet above him, and it wasn't struggling or vibrating. It was a dark, sleek wedge moving with eerie smoothness. The pilot reported that the American plane didn't even seem to have afterburners lit in the traditional sense. There was no massive plume of fire, just a distortion of air behind it like a mirage on hot pavement. As the Soviet pilot reached the edge of his flight envelope with engines beginning to surge and choke on supersonic air, the American pilot simply nudged his throttle forward and the Blackbird accelerated away, leaving the Soviet jet choking in its wake. The Soviet pilot had to abort, gliding back to base with engines that were practically scrap metal, cooked by just a few minutes of high-speed chase. This failure deepened the mystery because back in Moscow, the MiG-25 engines were some of the most powerful ever built, yet they suffocated at those speeds from air pressure that was too high and drag that was too great. How was the American engine swallowing supersonic air without choking? The Soviet intelligence apparatus began to suspect a trick, and they analyzed contrails, stole snippets of technical manuals from third-party contractors, and realized the American plane, which they now identified as the State Route 71, was using special fuel called JP-7, but the fuel alone didn't explain the physics. The engineers began to suspect the Americans were using a cycle they couldn't replicate. Was it a ramjet? A ramjet has no moving parts and works better the faster it goes. But a ramjet cannot work at low speeds, and you cannot take off with a ramjet because you need a turbojet to get off the ground. So was it two engines? Did the pilot switch from a jet to a ramjet midair? The spy photos showed only two exhaust nozzles, not four. The conclusion they reached was terrifying in its implication. The Americans had built a hybrid, a transformer, a machine that was a normal jet on the ground but metamorphosed into something else in the sky. But admitting this was one thing, while understanding how to build it was another entirely. The Soviet material science lab presented a major hurdle as they struggled to manufacture titanium of high enough purity to withstand the heat, let alone create the complex moving geometry required for such an engine. As the 1970s began, the Blackbird became a legend in Soviet ranks, the ghost that couldn't be caught, and radar operators would simply log the track and watch it go, knowing there was nothing they could do. The investigation had failed to produce a counterweapon, and they'd built the MiG-25 to kill it, but the MiG-25 was a sprinter trying to catch a marathon runner. They knew what it was doing, flying faster and higher than anything on Earth, but the how, the secret of the engine, remained a black box. They didn't know the answer wasn't just in the engine itself, but in the plumbing around it. They didn't realize the Americans had decided to stop fighting the wind and instead had invited the storm inside the engine. While Soviet engineers in Moscow chased ghosts and debated thermodynamics, the answer to their riddle was sitting under hot California sun in Burbank behind a chain-link fence at the Lockheed Advanced Development Projects Division, better known to the world as the Skunk Works, where the air smelled of jet fuel and epoxy, not fear. The man running the show was Kelly Johnson, a genius with a reputation for doing the impossible, and Johnson and his team had realized early on what the Soviets were just beginning to suspect, that standard jet engines were useless for the mission because they needed to fly at Mach 3.2 to outrun missiles. But at that speed, the air entering the engine is hot enough to melt turbine blades. The American solution wasn't to build a stronger engine that could fight the heat. Their solution was to build an engine that changed its own anatomy mid-flight. They selected the Pratt & Whitney J58 engine, which on a test stand sitting still was a powerful but fairly standard turbojet that screamed and burned fuel and generated thrust. But the magic wasn't in the engine itself, it was in the massive structure built in front of it. If you look closely at the State Route 71, you'll see two giant sharp cones protruding from the engine inlets. And these aren't just for aerodynamics, they're the secret weapon. These cones, or spikes, were movable, controlled by a complex analog computer, a mechanical brain of gears and cams that could slide the spike forward and backward up to 26 inches. And here's the genius that baffled the Soviets. When the Blackbird sat on the runway or flew at subsonic speeds, the spike locked forward and air flowed in smoothly, so the compressor spun and the engine worked like a normal jet. It sucked, squeezed, banged, and blew. But as the pilot pushed the throttle forward and the plane crossed Mach 1 then Mach 2, the computer woke up and began to retract the spike deeper into the engine throat. And at Mach 3, when the air hitting the front of the plane was a violent supersonic shock wave, the retracted spike was positioned perfectly to capture this shock wave and trap it inside the inlet. Instead of letting that shock wave destroy the engine, the shape of the inlet slowed the air down from Mach 3 to subsonic speeds in a fraction of a second, and this massive reduction in speed converted the kinetic energy of the air into pressure, immense pressure. So the air wasn't just entering the engine, it was being rammed into it with the force of a hydraulic press. And then came the second trick, the one Soviet pilots couldn't see. Inside the engine housing, Johnson and the Pratt & Whitney engineers installed a series of bypass tubes, essentially trapdoors, and when the pressure became too high and the air too hot for the delicate turbine blades to handle, the engine opened these doors, and the massive rush of supercompressed air didn't go through the core of the engine. It went around it, bypassing the compressor, the burner cans, and the turbine entirely, being piped directly into the afterburner at the rear of the plane. At that moment, the J-58 ceased to be a turbojet and became a ramjet. In a ramjet, you don't need a compressor because the speed of the aircraft compresses the air for you, and the engine core, all that complex spinning machinery, was reduced to a simple pump just keeping the flame lit, while the real thrust came from that bypassed air mixed with fuel and ignited in the massive tailpipe. This explains the impossible phenomenon the Soviet radar operators witnessed, because in a normal jet, the faster you go, the harder the engine has to work to suck in air, and the more fuel it burns to keep spinning. But in the State Route 71, the faster it flew, the harder the air rammed itself into the engine. So the engine actually had to do less work at Mach 3 than it did at Mach 1, and the efficiency went up. At Mach 3.2, the inlet design, that spike in those bypass doors, was generating 80% of the total thrust, and the engines were essentially coasting, being pushed along by the sheer force of the air they were swallowing. This was the cycle the Soviets couldn't replicate because the Americans had turned the enemy, that crushing air pressure, into the propulsion source. To fuel this beast, they couldn't use normal kerosene, which would boil and explode in the tanks at those temperatures. So they developed JP-7, a fuel so stable you could drop a lit match into a bucket of it, and it wouldn't ignite. And to light it, they had to inject a chemical called triethylborane, which exploded on contact with air, creating that signature green flash you see in footage of the Blackbird starting up. While the Soviets tried to build engines with brute strength, the Americans had built a musical instrument that required precise tuning, because if the spike was off by a fraction of an inch, the shock wave would be unstarted and spat out of the front of the engine, causing the plane to violently yaw and potentially break apart. But when it worked, and it did work, it was untouchable. The pilots in State Route 71 suits cruising at 85,000 feet were flying the only machine in history that got better, stronger, and more efficient the closer it got to the limits of physics, flying a miracle of engineering that turned the atmosphere into fuel. And down below, the Soviet pursuit was about to hit a brick wall. The turning point came not in a laboratory, but in the terrified report of a Soviet pilot pushing the pride of the USSR to its breaking point. It's 1972, and the location is airspace over the Sinai Peninsula, where the Soviet Union has deployed its secret weapon, the MiG-25 Foxbat, to Egypt to counter Israeli Phantom jets, but their real target is the high-flying American reconnaissance flights. A Soviet pilot with call sign 831 is vectored to intercept the target moving north at Mach 3.2, and this is the confrontation the Kremlin has been waiting for. The MiG-25 is fully fueled, armed, and stripped for speed, and the pilot engages his afterburners as the massive engines roar, dumping gallons of fuel per second. The 25 accelerates through the sound barrier past Mach 2 in a violent shudder as it punches through the dense lower atmosphere. And at 40,000 feet the pilot is doing Mach 2.5 while looking at his instruments and watching engine temperature gauges climb into the red zone as overheat warning lights flicker on. He has strict orders not to exceed Mach 2.8 for more than 3 minutes, because if he goes faster the engines will suck in their own compressor blades. But the target is still above him, and crucially, it's pulling away. The pilot makes a desperate decision and overrides the safety limiters, pushing the throttle past the detent and dumping raw fuel into the tailpipe, and the MiG-25 hits Mach 3.2 as the plane screams and paint on the nose cone begins to blister from friction heat, while the cockpit glass radiates heat like an open oven door. And then he sees it through the haze of high altitude. He spots the State Route 71, and it's not vibrating, not struggling. It looks like a silver dart suspended in motionless oil. And then the Soviet pilot witnesses the impossible as he sees the exhaust plumes of the American plane change. They tighten and turn into a series of perfect, glowing diamonds, shock diamonds trailing behind the engines. The State Route 71 doesn't bank away or dive. It simply accelerates and walks away from the MiG-25 as the Soviet pilot watches helpless while the American plane vanishes into the curvature of the earth. His own engines begin to surge violently with compressor stalls that sound like cannon fire going bang, bang, bang. And he chops the throttle and dives, praying his aircraft doesn't disintegrate. When he lands back in Egypt, the ground crew is horrified because the engines of the MiG-25 are destroyed with turbines fused together, and the heat was so intense it warped the steel fuselage. The aircraft is a wreck because it flew at Mach 3 for 5 minutes and effectively killed itself to do it. The report of this incident made its way to the desk of the chief designer in Moscow, and this is where the shock finally hit home as intelligence reports had pieced together the mechanism of the J-58 engine. They laid the schematics of the American engine next to the wreckage of their own MiG-25 engines, and the realization was a gut punch to Soviet ego. They're not fighting the pressure, a senior analyst reportedly said while staring at diagrams of the bypass tubes. They're surfing on it. The Soviets realized that while their pilots risked their lives to push a wall of air out of the way, the Americans had built a machine that swallowed the wall, and they understood now that the SR-71's engine efficiency increased with speed, so that at Mach 3 the State Route 71 was burning less fuel per mile than it did at Mach 2 because it was in its natural habitat while the MiG-25 by comparison was drowning. But the reveal got worse because to build a plane that could survive continuous heat, 500 degrees on the skin and 1,000 degrees in the exhaust, you cannot use aluminum, which turns to soft putty at those speeds. You need titanium. The Soviet Union sat on the world's largest reserves of titanium, or it was a strategic metal strictly controlled, and they assumed the Americans who had very little titanium would be forced to use heavy steel like the MiG-25 or give up entirely. Then came the final humiliating piece of the puzzle as the KGB discovered a network of shell companies. Dummy corporations set up in third-world countries, supposedly buying titanium for pizza ovens and bicycle frames, and the paper trail led back to the CIA. The silence in Kremlin meeting rooms was deafening because the Soviet Union had sold the United States the very metal used to build the spy plane that was now humiliating them. They had mined the ore, refined it, and shipped it to the enemy who used it to build a fuselage capable of withstanding the heat that melted the MiG-25, and the impossible engine was housed in a stolen body. The futility of the Soviet response was now crystal clear as they had built the 25 Foxbat as a counter, and it was a terrifying machine in its own right, fast, and armed with massive missiles and rugged. But it was a point defense interceptor that could sprint to the corner of the block, bark, and come back, whereas the State Route 71 was a marathon runner that could sprint the whole race. The Soviets tried to upgrade their missiles with the S-200 system designed with a massive warhead specifically to reach the Blackbird, and they developed the MiG-31, a much more sophisticated interceptor with phased array radar and data links designed to hunt in packs. But the physics remained the ultimate barrier. Even with the MiG-31, the intercept window was seconds long, and if the calculation was off by a degree, the missile would miss. And if the State Route 71 pilot simply turned slightly, the missile traveling at Mach 5 couldn't turn tight enough in the thin air to track it. The revelation was absolute because the Americans hadn't just built a faster plane. They had mastered a flight regime that the Soviets could visit but could not live in. And the J-58 engine wasn't just propulsion. It was a thermal management system that used the violent energy of the atmosphere to feed itself. The Soviets were left with a warehouse full of wrecked MiG-25 engines and a sky full of ghosts they could see, track, and hate, but could never touch. The final scorecard of the Cold War skies can be summarized in two numbers, 4,000 and 0, because over the course of its service life spanning 3 decades, over 4,000 missiles were fired at the State Route 71 Blackbird from North Vietnam, North Korea, Libya, and the borders of the Soviet Union, and every single one of them failed. The Blackbird, the plane that broke the rules of thermodynamics, was never touched by enemy fire, and this statistic isn't just a testament to pilot skill. It's mathematical proof of an engineering checkmate. By the late 1980s, the Soviet Union had effectively bankrupted itself trying to build a roof over its empire. They had constructed thousands of missile sites, produced over 1,000 MiG-25 interceptors, and over 500 of the advanced MiG-31 aircraft, and trained entire generations of radar operators to look for the fast mover. The economic disparity was staggering because the United States had built only 32 State Route 71 aircraft, a tiny fleet. Yet this handful of black jets forced the Soviet Union to spend tens of billions of rubles on a defense network that, practically speaking, did not work against the primary target. This brings us to the true legacy of the mystery, because the J-58 engine wasn't just a propulsion system. It was a symbol of the widening gap between two distinct ideologies of innovation. The Soviet approach was logical, robust, and industrial, where they looked at the problem of needing to go fast and applied more power, building bigger engines and steel frames and stronger rockets in a philosophy of brute force that produced the MiG-25, a magnificent machine in its own right, but one fundamentally limited by the materials it was made of, a sprint runner trying to keep up with a bullet. The American approach, epitomized by Kelly Johnson and the Skunk Works, was different. It was experimental and expensive and seemingly reckless as they looked at the problem and decided to change the physics of the environment, realizing that fighting the atmosphere was a losing battle. So they redesigned the engine to feed on the violence of the speed. They built a plane that leaked fuel on the runway because the panels were designed to fit only when expanded by heat. They built a plane that grew 6 inches longer in flight. They built a plane that required a separate starter card with 2 Buick V8 engines just to spin the turbines up to speed. To Soviet engineers who prioritized reliability and mass production, the State Route 71 was an abomination. It was too complex, too fragile, too demanding. It shouldn't have worked, but it did. The psychological impact on Soviet military leadership cannot be overstated because for 25 years they lived with the knowledge that the Americans could fly over their most sensitive installations, take high-resolution photos of their backyard, and be home in time for dinner, and there was absolutely nothing the Red Army could do about it. It created a culture of paranoia and forced them to hide their best secrets in bunkers knowing the sky was always watching, and it accelerated the collapse of their economy as they desperately tried to close a technological gap that widened every year. When the Iron Curtain finally fell in 1991, American pilots and Soviet pilots finally met face-to-face at air shows and conferences where the old adversaries shared vodka and stories, and the Soviet pilots, men who had flown the MiG-25 and MiG-31, asked the Americans the same question over and over again. How did you keep the engines from melting? When the Americans explained the bypass tubes and moving spikes and thermal expansion joints, the Russians were often silent because they understood the physics but were baffled by the audacity. They marveled at the fact that a government would approve such a risky, insane design. The State Route 71 was retired in 1990 not because the Soviets caught it, but because satellites and budget cuts finally did what 4,000 missiles could not. Today, the remaining Blackbirds sit in museums, cold and quiet and no longer leaking fuel. But if you stand next to the massive inlet of a J-58 engine, you're looking at the artifact that won the Cold War not with a bang, but with a sonic boom. And it stands as a reminder of a time when engineers stared at the impossible thermal wall of Mach 3 flight, and instead of turning back, they decided to simply open a door and walk right through it. The Soviets spent decades looking for a weapon to kill the beast, never realizing that the beast was powered by the very thing they were trying to protect, the air itself.